Yeah, I will re-record just to clear. NEPHIO is a middleware which uses Kubernetes, and we started with earlier presentation on KubeStack, and so KubeStack can be used for NEPHIO middleware. And the architecture here is, uh, yeah, so it's a Linux Foundation project recently funded by Google for a year, started on May 3rd, and there are around 20 members, and still the TSC formation is not over. So majority of these participants are cloud service provider, telecom service provider, and network equipment providers who have a stake in cloud native implementation of telco services. So as we said, we have the journey has started on the cloud native, but it is evolving. It has relationship to what we need to do today, in the sense that we are moving from DNF to CNF, and as physical network functions are being implemented in 5G use cases, but that needs to be converted to container and not just VNFs. So the cloud native way of implementation requires special interfaces and images and creation and various other things. So the industry is looking forward to faster, simpler, and easier work for achieving optimization and agility. And the best practices in computer science, which is normally modularity, abstraction, separation of concerns, resource sharing, and loose coupling. So these are the 5 guiding principles of NEPHIO to simplify the cloud native deployment. So you can see that I spoke about these 3 network. These CSP, TSP, and NEPs, they generally take the network function from vendors and communication service from providers and deploy it on the hyperscalers. So if you look at cloud native principles, there are 12 of them. We call it as 12 factor. And those are the 12 factor best practices. And that includes, like, you start with compatibility and then use the k8s distro, then you make it scalable, vertical, and horizontal. Then you configure using the open configure CRDs or operators, as earlier mentioned by Parth. So you have to look at the observability and Prometheus we covered previously, and that is one of the ways to get the time series data base for the KPI and resilience of the platform. Then for portability, you need to make sure the applications are written in descriptive with the descriptors, declarative descriptor. And obviously the pain point is always the network and network abstraction, because CNI is hardware dependent. So how to make it abstract independent of CNI is one of the key premises of portability for the NEPHIO. Then that is where Parth mentioned to you in the NEPHIO previously, saying that you need to look at routers and switches which we can interface using the KubeStack. So that's a good area for us to look at. Then you have got, obviously, as a DevOps principle, it should be installable and upgradable to be able to maintain multiple versions on the production side. And then CI/CD across the platform, because you need to have what you call the parity of development deploying in a similar way. So similarity, and that is why you need a continuous integration and continuous deployment. And it should be open as a service. That means you should be able to get the RESTful API. That is where the cloud platforms each need to provide a RESTful API to be able to absorb, which is common across, like onboarding of VNF or CNF. Then it should be traceable telemetry, as we had seen the number pointing out to the telemetry of Grafana and other tracing mechanism with CNC for open trace, open telemetry, etc. It should be loggable, like a lot of people use Splunk or some of those logging tools. And those are open telemetry also provides that. And the CSPs definitely want that it should be, experience should be, quality of experience, quality of service should be better with CNF and Kubernetes. So these are the requirement, 12 factor requirement. Now you will find that besides 12 factor, which are standard for the cloud native implementation does something called X factor. And so Cloud Native 12 factor we already covered earlier, and it's available on the https 12factor.net. You can refer to that. The X factor, the difference between the 12 factor and the X factor, which is provided by CNF, is that there is a difference in that. So what is similar? Similarity between X-CNF and 12 factor is that you use declarative presentation of all the software, hardware, and all the project. You have a clean contract in the sense you have proper interfaces and portability is maintained. You have suitable deployment on a modern cloud. Modern cloud means all usually the public clouds like Google Cloud, the Amazon, AWS, and Azure. These are the public cloud, as well as private clouds like OpenStack, etc. And service providers implement one of those, and our enterprises use one of them. So there should be vendor to vendor differences should be minimized. And not only that, here minimizing the divergence between CI/CD, as we said, that means each may have different CI/CD, but they are functionally similar. And scale up with the architecture is important. That is the 12 factor, which is similar with CNF, X factor. But X-CNF has got differences in the sense that here you not only talk about the workload, but you talk about the workload or payload types, like what kind of function chaining you are going to use, like whether you are going to use, and because network is the key. CNI is a networking interfacing is a key thing, and therefore the protocols are important. So payload type is recognized as Ethernet, IP, MPLS, VXLAN. So these are the things which are used. And additionally, you can see that mechanisms that are supported for optimization or acceleration, like SRAOV and memory interface and beyond this, and those are the various things. Plus, we have got Linux Foundation as some of the projects like DPP, which are at the Linux level, kernel level, and then OVS is for the OpenFlow and for the Open Virtual Switches, which is one of the main themes for Linux Foundation to support the mechanism for Linux interfaces. And the third one is obviously we want everything to be microservices. So you have to disaggregate everything, whether it is database, whether it's a queue, memory cache, all these to be orchestrated and managed through network interfaces. So when we talk about the cloud native, we have to understand that not only the 12 factor, the 3 X factors which are mentioned here, are also part of the NEPHIO to support, to leverage. So NEPHIO is going to obviously leverage this for 5G use cases. Now 5G, if you look at the service-based architecture, you have got the 3 main important functions: the access management function, the session management function, as you see, and the user plane function. So this is in the control plane, this is in the user plane. User plane is aggregated, that means if you have a user equipment, a mobile phone or a tablet or whatever, you connect to the radio access network through the access management function, where you get the functions authenticated and then followed by the RAN being passing on, the connecting the UE to the data network or to the application where a package tunnel is established, and it is at the layer 2 and then passes on to the layer 3 and on to the full stack, so that session can be managed. Session is at the layer 5. So session management function is what we are looking for NEPHIO. It's a network function. It includes several discrete functions. So one of them is like service registration, service discovery, onboarding of CNF, sessions create, update, delete, which is the standard code, and IP access management. So you'll find that there are at least, even with simple section management function, I can identify 1, 2, 3, 4, 5 microservices. So these are 5 services. If you say that the session management function is the use case, then we have to deal with these 5 use cases, and that will be not only with the control plane side of it, also for the user plane side of it. So here what I have mentioned is mainly on the control plane side. Of course, when you create the session, you create the packet or PDU packet data unit, which needs to be end from user equipment to the application function or to the data network, depending upon, or you need to, if it is a voice call or something. So NEPHIO use cases which we are going to address is session management function. And we are trying to tie it with the coupon stack and see how we can enable the NEPHIO for the 5G SMF use case. And this is in the same thing. I can show you example. This is a one of the examples where you can see the details here. So you can talk to GNB, and this is when you say GNB, it is a G node B. E node B is for the 4G, and GNB is for the 5G. And so UE talks over the interfaces N6 to GNB and talks to the access management function. UE N1 access management function is a part of the what you call authentication services, and it talks here and gets the NSSF to get the slice that is needed and allocated, and which can be used over the eOTF after creating the session, the PDU session. SMF generally provides the IPAM or the IP address. So in the service-based architecture of next generation application protocol, there are non-access stratum, that is all these calls to get the clearance of the access and validate, that is subscriber validation coming from the user UDM and all that. That's a part of the non-access stratum. Once you have established connection, then you can go on and establish the data network and connect with the so session management function. Here it is describing through a service-based architecture. The earlier one, what we saw, was mainly a what you call standard design from 3GPP. This is nothing but a deployment and how they are deploying it. And we can look at the flow also. So this is the flow. UE establishes a session, and that establishing of requires service registration and creation of the service. So if you have the service which is already registered, then you discover it. And once you discover it, the session management function kicks in. It establishes the PDU session, and then it creates the session and allocates to the UE the IP, and the IP can handle. So our goal in this case is to follow the SMF 3BBTS 23502, which is the standard, and we'll try to see how we can engage with the NEPHIO team, and along with the coupon stack, we'll try to create the CRDs that are necessary. And you can see that NEPHIO is intent-based. So what it means is you always have a design studio, so build, deploy, and then control loop to state management, that is. So what we have is, we design the example, if you want to do session management function, then we have to design what does it include, what packages it should include, how do we ensure that it is following the policy of the resources, etc. And once we select the cluster where we want to deploy those packages for the session management, we can select those and deliver the package, and once it is delivered, it will be deployed. And once it is deployed, then you have to follow up whether the desired state is achieved. If not, then how do you get the loop back and try to find the metrics and ensure that it is managing to a desired state, which is what it should be always. So you can see that this can be deployed on any cloud. It could be a Google Cloud, it could be Amazon, it could be OpenStack, it could be anything. So depending on wherever you deploy, but the bottom line is it is on Kubernetes. So we can say if it is OpenStack, it will be OpenStack over Kubernetes. So Kubernetes is the infrastructure at the bottom where we will be implementing. All are going to be microservices. So example which I described was session management function. So we have to do all the 5 microservices or 6 microservices, and make sure that we create packages and ingest that into the deployment platform, which could be OpenStack, or it could be any of the Kubernetes distros. And that will be overlay. And on that overlay, once we do the intent-based delivery, Then we do the reconciliation and allocate resources and ensure that it is reliable and continuous. So this is the intent-based deployment for the coupon for the NEPHIO. So NEPHIO here exactly means it's a extension of Kubernetes. So normally Kubernetes controller. So if you use OpenStack, we have a Kubernetes controller. Or if you use, let's say, Red Hat Enterprise Edition, as we said, that could be one of the what you call the Kubernetes underlay or the Kubernetes cluster. Once there is a source, master is always the system, and target is the where the deployments is. So all our AMF, SMF, SMF in this case, all the components of 5G will be deployed on the target cluster. The target cluster being in this case, what we have, let's say one of the Kubernetes, this one, target clusters, then those target clusters naming will decide how the 5G NEPHIO will be used, because at the top of it you've got the SMO, they call it. SMO is nothing but a replacement of MANO. MANO is management and network orchestration. And SMO is service management orchestration. So part of the ORAN, you have the SMO which is driving. So you can see that end-to-end service orchestration and slice management comes through the SMO, which is the service management orchestration, or so-called MANO in the earlier days. And that is what has an open API, which will be talking to NEPHIO at the northbound. And NEPHIO, what it does is, it will take the Kubernetes cluster and Kubernetes and create operators which will enable the lifecycle management for the Kubernetes cluster itself, the target cluster, I mean. And that will be one of the extension, and we call it as O2. ORAN has got multiple interfaces. We call it as O2 management, and O1 is for the YAN model based CRDs, whereas O2 is for deployment. So we will be focused mainly on these two. One for the annotated HC, that is the one which we can deploy the coupon stack. So that is the management of the underlay, cloud infrastructure, resources, and all that. It could include switches, routers. It could include the stack itself for the Kubernetes for the target cluster, so that the parts can be created and recreated, and microservices for that can be maintained, which could be like, if it was OpenStack, then like we saw OpenStack microservices, similar thing. And on the operator side, we have the network function itself. So if I talk about network function being a 5G session management function, then those microservices like IPAM, the service registration, and those kinds of operators will have to be done by using a CRD. CRD means you have to have custom resource. That means you have to have a descriptor which describes. And descriptor has got two important, any Kubernetes descriptor, if you take, it has two important things. One is the specs, and other is the status. Specs usually provides the specification of all the things, including the namespace, the various labels associated, and notations, and most of it, which is like if it is a configuration, etc., are hidden. Most of it is hidden so that people do not know what exactly it contains, but one has to know as a custom resource descriptor extender, the specs and standard specs won't do. So for session management, what do I need to do? Oh, I need to have IP address, so I have to put an IP address there. Does it get from DHCP? Okay, so it is DHCP driven. Then I have to find out where is the DHCP. So all this is part of the specs. So specs needs extension, and that is what once the specs is extended, standard Kubernetes cannot handle it. It has to be handled by a custom resource operator, and therefore we call it as a external custom resource operator to enable those specs items which are added newly. And obviously, if you create new server like IPM service, then we need to know what is the status. Is it running? Every health check has to be done. So accordingly, the infra has to handle that. So some of the things will be infra-based, some will be NFV-based. So NFV is nothing but network function is containerized function, not the virtualized in the sense of virtual, but container virtual. because VNF we still use the term commonly. It can be used for uh, workload configuration as well as for automation. So our focus here, we put it that we definitely are more focused on O1, not 3GPP at this stage, but 3GPP will bring the specs, because in the default specs, everything that 3GPP claims may not be possible, and anyway, deployers have the option. They can follow the standard, yet they can differ from it in deployment. That's the goal. So this is the uh, crux of what is there in NEPHIO. And you can see here, we have extension to the Kubernetes API. So you can see that there is a NEPHIO is a whole of extension on the Kubernetes API in terms of infrastructure loop and intent-based deployment of NFV, our network function. And network function virtualization means NF containerization in our case. And the various package management and config management, you can use a config map to map it, but at the same time to automate, you better put it into upstream GitOps type of operation, so that one can, and they have got the various development plans, and we are in the early stage of it, but we want to be able to participate as part of the RCDU OR lab, OIP lab, as well as from the eOTF. And I think thank you very much.